So hello, my name is Dr. Francis Omonefe. I'm a exploration physicist for Sandy Consulting. So today I will be talking about reservoir crossplot and how to interpret crossplot in basic ways. So I will be using a PowerPoint sent to me, so pay attention. But if you have no business with how to interpret crossplot, reservoir crossplot, you can as well just scroll and pass. I believe you are seeing this video from LinkedIn or from our YouTube channel, so you can just follow me for more or subscribe to the YouTube channel. If you have any question, you can just leave it on the comment section, and I take my time to answer any question. I know I gain a lot from the academics, so this is my way of giving back to the academic.
Let me present this PowerPoint sent to me by one of my offline students. We have this petrophysical result where we have our zone 1 being sand formation, then our zone 2 shale and sand, then our zone 3 and our zone 4. Our resistivity value is from 0.2 to 20. Yeah, from 0.2 to 20. Then we have our density, we have our temperature, we have our petrophysical results, where we have our water saturation here, we have our porosity here, we have our volume of shale here, and we have our permeability here. So let's assume all our criteria are met. We use the right formula, we use the right ashes, the right equation to generate our petrophysical results, and we now came up with this basic result. From all indication, it is looking as if zone 1 and zone 3 is promising. The promising zone because it has sand formation, then it has a little bit of resistivity. You know, resistivity alone cannot be used to determine your hydrocarbon formation because it is affected by different factors. It is affected by porosity, fluid saturation, density, what have you. A lot of factors, formation, everything can affect your resistivity. So that's for that, and we have our density. We have our density deflecting to our left in this 2 formation. Then on the water saturation area, we have high hydrocarbon saturation in this area, in our zone 1 and zone 3. Then also we have favorable on PHIE, that effective porosity, total porosity and effective porosity. We have favorable value here. And also in our volume of shale, we have more sand and shale in these areas. Then in our permeability column, we see that these areas are more permeable than the other areas. So let's go to the cross plot. Let me use cross plot to characterize the reservoir. Now this is a cross plot of that reservoir. This is a cross plot of volume of shale versus effective porosity. Volume of shale versus effective porosity. Now this is a lithology indicator. Now how do you use this cross plot to indicate your lithology? Remember, this is for academic purpose. This is for academic purpose, and I will be as layman as possible. All our zones are shown in form of cross plots. We have zone 1, zone 2, zone 3, zone 4. Remember, our zone 1 and zone 3 were our zone of interest. And we know also from the results that our gamma ray value for those zones falls between 45 and below. Okay, let's just say 50. Our API for gamma ray value in those zones are below 50%. So they fall between the blue, the gray, the purple, and the green. Now, when you check this cross plot, you see that our zone 1, which have gamma ray value within those range, that's below 45, or let's say below 50 or below 60, are all in this zone. Let me pick a pencil. Pick a pencil and draw. Okay, so this area contain our zone 1 and zone 3 because they fall within the gamma ray values of API values below 60. So now these areas are seen as our zone 1 and zone 2. Now what does this cross plot tell us? It's telling us that this area have porosity of 0.3 between 0.2, 0.1, 0.2 to 0.3, and also have a volume of clay from 0.3 downwards. What this means is that we have our zone of interest to fall in the area where we have high porosity and low volume of clay. High effective porosity and low volume of clay. This is where this area falls under. And what it means is that it's a strong indicator of a clean sand formation. It's a strong indicator of a clean sand formation. Probably this formation is free from any clay content at all or any shale content. The other slides reads a cross plot of total porosity versus density. Again, let's check our color coding. Our color coding is the same gamma ray, and our zone of interest falls between this green and the purple, and this is the area where it is more concentrated. This is the area where our zone 1 and zone 2 are more concentrated because this area has clean sand formation. And what this means is that the combination of low total porosity and low density is a strong indicator of tight formation with a potential presence of light hydrocarbon. So let me go to the last one. So the last one, like as I said, this is our zone of interest, zone 1 and zone 2, where the lithology is between 60 and below. These are zone of interest, and this area falls between low density and high resistivity. Falls between low density and high resistivity. So what this means is that density versus resistivity also indicate that this formation could contain gas. This formation could contain gas because a combination of low bulk density and high resistivity in the formation is a strong indicator of the presence of hydrocarbon, particularly gas. So this cross plot is showing us that our zone 1 and zone 3, which falls within these gamma ray values, contain gas according to our cross plots. Yeah. So that's the basic way of interpreting this thing. So you just look at the clusters and see the area where it actually falls, where it's clustering, and interpret according to your result. So if you found this tutorial useful, I would say you should subscribe or follow me on LinkedIn, ask questions,